All right, Chem 11, we are back for the fifth and final lecture in our naming compounds series. All right, this is the last one, I promise you. All right, so as usual, here's our PowerPoint lecture notes from our D2L site for the course. You should have downloaded those already and made my notes your notes. And then, of course, we've got the whiteboard here and another special guest appearance by The Rock and telling you, do your work, jabroni. Anyway, today we're doing binary covalent compounds. All right? Now we know a binary compound has just two elements. And if it's covalent, it means that it's a nonmetal and another nonmetal. All right? So there's no ions formed here, right? When the rock meets up with another rock, the rock doesn't beat up the rock shares with the rock, right? That's what the rock says, if you can smell what the rock is cooking. Anyway, so here's the thing. We've got two nonmetals, they're sharing electrons. So there isn't a stealing and beating and taking and they're all mine and not yours and you took my electrons and all that. There's no positive and negative ion, right? So we have to have a different system of naming here because we can't put the positive ion first and the negative ion second if there's no ions. All right? So how do we name these things? Well, they're going to have two names, one for each of the nonmetals involved, and we're going to use prefixes. You've seen these prefixes before in grade 10. Here they are here. These are the covalent compound prefixes. All right? So we've got 1 is mono, 2 is di, 3 tri, right? 4 is tetra. Sometimes you'll see quad put in there. Tetra, the easy way to remember tetra, Tetris. In the video game Tetris, all the little blocks that fall from the sky have 4 smaller blocks making them up. 4. Penta is 5. These two, hexa and hepta, they often get confused with each other. Just remember it this way. Hex and 6 both have an X in it. All right? 6 and hexa both have an exa. All right? 7 is hepta, octopus, octa, right? 8, nana looks like 9, and a decade has 10 years. So easy enough to remember those things. All right? And of course, we do borrow from the earlier rules where the second element is going to have the IDE ending to it. All right? So we're going to shorten up the name of the second nonmetal and add "ide." This means the two of them are together, right? So if I say nitrogen dioxide, that "ide" means the nitrogen and the oxygen are together. All right? Now, an interesting thing. I use all of these for the first element or the second element except for mono. Mono, I'm going to put a little star by it. Mono only gets used on the second element. We never start off a covalent compound with mono, right? Think of carbon dioxide. We don't say monocarbon dioxide, right? Carbon dioxide is CO2. I don't say monocarbon dioxide, it's just carbon, right? Dioxide. Now, if I have something like this, right? Di and tri and all the rest of them, right? This would be a di, this would be a tri using these rules. I have to use them. So 2 and above I use on everything, the first or the second element. The mono, it only gets used on the second element. Here's another example. Carbon monoxide, that's a product of an incomplete combustion. Carbon monoxide. They both have a 1, but only the second element uses mono. So that's why I put the little star there. I only use mono on the second element. All these other prefixes can go on the first or the second. All right? So let's do a couple of examples here. And we've got N2O and CCl4. So N2O and CCl4. All right? The first one here, N2O, I see 2, so it's di nitrogen. The name of the first element doesn't get I'd. It just stays the way it is. Like the metals, right? The first element, I don't put IDE. Only the second one. Now I've got a 1 here that I can't see, and 1 is mono. So it's monoxide. I don't put double O there, right? So monoxide. Dinitrogen monoxide. The next one, C. That's carbon, not monocarbon. I know I only have 1 of it, right? There's only 1 of these, but I don't put monocarbon, it's just carbon. And 4 chlorines is tetrachloride. Carbon and 4 chlorines. Carbon and 4 chlorines. 2 nitrogens and 1 oxygen. 2 nitrogens and 1 oxygen. All right? Rock, I got to move you out of the way. Sorry. The Rock won't be pleased with me. I'm sure I'll pay for that later. But I'm willing to risk it for your education, darn it. All right, a couple of more. Oh, wait, let's see if we're right. Oh, if it's online, it must be true. Abraham Lincoln said that. All right, so we'll do a couple of others here. P4O10. P4. 4 is tetra. P is phosphorus. Tetraphosphorus. I don't put "ide" on the first one. Tetraphosphorus. 10 oxygens. Decoxide. I get rid of the A. It's not decaoxide. I don't put the 2 vowels together like that. All right? And we can do another one here. Let's do N3Cl7. 3 is trinitrogen, and 7 is heptachloride, right? That "ide" ending keeps showing up at the end, and that's the proper way, right? We can also do XeF6. If we look at this one, xenon. Now, xenon is a noble gas, but every so often xenon sneaks out and makes some covalent bonds. Hexa is 6. 6 and hex both have X. And fluorine becomes fluoride. Anyway, that's all that's to those. You guys have done these before. So that's it. Short lecture today. If you have any questions, comments, or concerns, throw them into the comments section below this YouTube video, or reach out to me through Edsby if you're in my class, or if you're in my class, raise your darn hand. Speak to me. Let me know. Ask questions. You just can't sit there and not know. Anyway, that's it for today. Hope it's crystal clear and you understand. I'll talk to you soon. Bye-bye.